I want to go back and go a little bit more into the running of the harvesters and the loading of the trucks, because that's kind of the next big thing coming that you guys are going to be involved with, and I want to be sure that we've covered all those bases and not left something that I assume makes sense but maybe didn't. So with respect to the harvester, we run as fast through the field as we can and not overload the side elevator. If we start seeing potatoes rolling backwards down the elevator, we're going too fast. We're putting too many potatoes on the machine for its capacity, so we got to slow it down. So in a field that has a lower yield, we can go a little quicker. A field with a higher yield, we got to slow down a little bit. So that's the governing factor in how fast you can run. And that assumes that everything is pretty close to optimum. When you have difficulties because of maybe there's sandy ground on one end of the field, but it's heavier soil on the other end, or you're concerned about depth because the planter didn't plant them all the same depth. The amount of soil you bring onto the harvester determines to a certain extent how fast the primary's got to run. So if you're bringing your rows up the machine and there's about 4 or 5 feet of nothing but potatoes at the top of the primary, you didn't bring enough soil. But if you got enough potatoes to fill your side elevator, you can't go faster. So you got to go deeper. Bring more soil in, because that rollback on the top end of the primary can do a lot of damage. So we don't want those potatoes kind of breaking free and moving around in the upper end of the primary chain, because that can damage them quite a bit. That primary chain's not cushioned. It's usually bare steel. And so it's a place where difficulties can occur. So carry enough soil that you can see your crop, the top side of almost all those potatoes, in the last 18 to 24 inches of the top of the primary. And if you're carrying soil too much beyond that, slow down or raise your primary knife, but don't get up there where you're cutting them. So there's limits to how far you can go in each adjustment. So we want to get rid of the soil on the primary. That's its purpose. The secondary is there more than anything else to separate the potatoes from the vines. That's all it's supposed to be doing.
Well, if you weren't carrying enough clay at the top of your primary, instead of going deeper, why wouldn't you slow the ends down a little bit and speed up your burn speed?
Well, you can do that unless you're overloading the side elevator. If your crop's big enough that you're maxed out there, then you don't want to do that, because you're going to get a lot of rollback on the side, which is going to damage a lot of them. Yeah. So when your side elevator is running pretty much at capacity, that kind of sets your ground speed. Then you look at your primary, how am I doing on dirt? Am I carrying dirt too far over? If I am, I'm going to slow down. So I'm going to run a little under capacity because I can't separate the potatoes from the dirt very well. If I'm running out of dirt and I got potatoes rolling on the top end of the primary and hitting each other, then I want to drop the nose down a little bit deeper, bring more soil up to help keep them from bumping around with each other.
So when the side elevator and the rear cross,
You generally can't see the rear cross. Yeah.
there really shouldn't be any amount of clay going up there.
Shouldn't be any dirt there, other than what's going to stick to the potatoes maybe all the way into storage. If it's a kind of a wet day, that can happen. But you want to get rid of all that dirt that you possibly can on the primary. And if that works good, then everything else kind of follows suit. So if you see dirt going over onto the secondary, then you know your bruise is going to go way up. Because every single potato has dirt on it. When it makes the fall, the extra weight of the soil plus the potato itself hits harder. And the drop height there is 8, 9, 10 inches, somewhere in that range. And so you're on the ragged edge of causing bruises to begin with no dirt on them. You put the dirt on there, now you've exceeded it. So a good portion of your crop, maybe half of them, will be damaged in that one drop.
So you were saying earlier, if your knife or your shear is set on the same angle as what your primary digger bed is, that row should be starting the first half of your primary. That row should follow right up there.
Oh yeah, yeah, absolutely.
It shouldn't be breaking up and bunching.
No.
Hold on.
No.
Okay.
It should be just a flow, and because the primary is running faster than your ground speed, you're stretching that out. And that allows room for the soil to fall through between the potatoes. And that's really what we're trying to do. That's why the ground speed is always slower than the primary. So we're stretching that row out and making space for the soil to get through those chain links and off the machine altogether. And the chain's there just to keep the potatoes from falling through and brings them to the secondary. So there's fine tuning there. When you're running a machine, it's not uncommon to change speed 2 or 3 times in one pass across the field. It's not uncommon to raise and lower the primary knife a couple times. So it's not just set it, put her in gear, and don't look back. Because someplace it's not going to be right. And the longer that happens, the more cost there is involved in crop loss because of quality issues. And so right now that crop is in fabulous condition. There's just nothing wrong with it. So all the damage that might occur is going to occur from the time we dig them until we pack them. So there's plenty of opportunities for problems to develop. We just don't want to give those opportunities a chance to happen. So like the thing I mentioned earlier this morning, prevention works, cures don't. So if we can prevent a problem and not get a bruise, we've done what we need. If we get a bruise, we can't cure that. Can't back that up. So we want to save the quality that's in that field right now and get it through this line here into a container, a bag or a box, and down the road as undamaged as it is out there in the field today, or as close to that as we can. So as your temperatures change, your practices in the field, the way you run that harvester, are going to change. Probably the soils are going to get wetter over time. That's a normal fall. They start out fairly dry and they get a little wetter as you go. And so the right primary speed today, if you were to go out there and dig, might be fairly different. It might be, say, 1.3 times ground speed. But 3 weeks from now, after a couple more rain episodes, you might be 1.6. And so don't get in love with the sprockets that are on your machine, because they're going to have to come off and others go on to replace them. Because there isn't just one right one. We have to adjust the machine to our conditions. We can't adjust the conditions to our machine. So we have to be on top of it, watching to see what's happening in the field, so that when we see something occurring that isn't what we want to see, we go fix that. And the quicker we spot it and the quicker we fix it, the less costly it'll be. And that's the whole goal. So the challenges of getting the potatoes around the digger without injury are real. They're pretty serious. But at the same time, the challenges of getting them into the truck without injury are equally important, because that's a place where a lot of damage occurs. once they get in the truck, then the unloading process, be that the storage or right directly into the line, is going to have its own challenges, but usually those are small in comparison to the things going on in the field. The field is the big concern. That's where the big problems might occur and where the attention needs to be focused. So there's more than one right way to do things. There might be several right ways. Part of it's going to be limited to the capabilities that you have, the kind of machines you run, how good the people are that are running them, the kind of trucks you use. All that is part of the equation. And so you've got to make everything work as good as you can figure out how to do it. And right now, before the harvest starts, everybody's in a pretty good mood. Y'all can get along pretty well, no problems. That last day of harvest, you don't want to say nothing to nobody because you might get your head bit off. Because it's a long haul and tempers get short at the end. So keep in mind that open communication, that feedback from every source is so critical, because the decisions that are made by whoever's making them are only as good as the information he has to work with to arrive at that decision. If there's things he doesn't know about that need attention or need consideration, make sure he gets that information, whoever it is. Because that's going to make things work or not. And in potato production, there's really no lone rangers, it's teams. And because I get to travel all over North America and I see an awful lot of farms and the way things are done, I see a large variation in how well folks work together at critical times like planting and harvest. And the farms where everybody's on the same page and got a good attitude and talking to each other and making sure all the details are covered, those are fun places to be. When everything isn't going so good, you kind of like to be somewhere else. So anything that comes to mind, questions on getting that harvester set up? Get that primary nose in line with the top side of the primary chain. Make sure that primary chain is losing the majority of its dirt before it gets to that top 18, 24 inches. You can have dirt between the potatoes up there, that's fine. But you don't want potatoes that are buried, because that's extra weight and that's going to make them hit harder when they drop onto the secondary. And so we want to be sure that we're not making the problem worse by carrying too much dirt. And the philosophy or the adage that, dirt's a cushion would work pretty good if we didn't have gravity. But because we have gravity, the whole hill starts getting closer and closer to the chain until the tubers come to rest against it. All the dirt below the tubers is the first to fall through. Then the dirt between them, and then the soil above them. So we want that soil above them gone before we get to the top of the primary. We can still have some of that filtered over in between them, and that's okay, as long as they're not buried. And then when you build that tier in the truck, as you get out there and start putting that together and trying to make that system work for you, you'll find it's not that complicated. There's a lot of farms all across the country that do it that way. And they do a very nice job. So it's not something that you're the test pilots and the guinea pigs for somebody's new ideas. They're not new. They've been around for about, I'm going to say 18 years. And so there's a few custom harvester folks in various different regions. And they're the ones that have made the most use out of that person with the smaller hydraulic valves that stands up on the picking table, because they're often paid on tonnage and bruise free. And you know, they could go in and tear a guy's crop up if they weren't incentivized to be careful with it.
If you have an employee though that's running hydraulics instead of picking rocks, I mean, how much damage is the rocks that are getting by because they're running hydraulics instead of picking rocks? Like, you know, if you're in a rocky field, how much damage are you causing the potatoes having all these large rocks go by?
It's a problem. I would be sure I had enough people up there that if one of them stopped to blow his nose, it isn't going to affect the problem. So if they're not blowing their nose but they're running the hydraulics, it's the same thing. They're not picking rocks for a little bit. We don't fill the whole truck that way. We just get that pile up high enough that the operator in the tractor has visual on it. And then he can take over and do it, and they go back to whatever they're pulling. So it's important. If you only got one person up there, there's no rocks going to get pulled at that point. Odds are that by the time a rock gets clear up onto the picking table, it's already done a fair amount of damage. And it's kind of the last chance to get rid of it, but after the fact. If we could figure out a way to pull them off the primary, that'd be a better choice, but haven't found any volunteers yet.
Has there been any, I just think about our bulk boxes, there isn't any screening that's put in them where the operator, the harvester operator can see through them, is there? No, that doesn't
Not that
work.
I've seen.
No.
There's a couple things you can do on the harvester if you want to make the machine last a little longer, and maybe you've already done it. There's a white plastic product called UHMW. It's ultra high molecular weight, is what that UHMW stands for. It's extremely durable. It's kind of like sheets of Teflon. It'll outwear steel 3 to 1. And on the side rails of the primary, they put that UHMW on there, use elevator bolts to bolt it in place, and it'll make that machine last way, way longer than it would. It'll wear right through and have to be welded or fixed some way later on. And it's so slick, kind of like Teflon, that it's not abrasive. So you're not skinning potatoes if you got a lot of soil on them while they're traveling there. So where you've got wear spots, the UHMW works really well. And it's available in lots of thicknesses. Usually 1/2 inch is what most guys use on the diggers. And it's good material. So we got our crop into the truck. Now, depending on how long your haul is, if you're 5 minutes away, don't worry about filling all the corners. That's not going to save you anything. It might cause you more problems than benefits. So once the truck is reasonably full and not going to get a load ticket from the regulatory folks, get it out of the field on its way. And the more potatoes you put in the load, the more down pressure there is at the bottom. So the harder it is to break those free and get them flowing out the back gate without damaging. And it used to be, it wasn't real uncommon when we had plywood boards in the bottom of the trucks, you'd see guys up there with cowboy boots stomping potatoes to get them to flow. Well, it was before we had air fans on the harvesters, and there was a lot more dirt going in the trucks, and they would lock up with the dirt and didn't want to go out. But those cowboy boots are kind of hard on the bruise levels. So there's a certain amount of dirt you can remove with the harvester. You can't get it all, but the cleaning equipment where they're being unloaded get most of it. And you can overload those folks too if you put, a lot of dirt in that truck so that it weighs about 1/3 more than it should. it's going to create some problems at the other end. And so don't create a problem for somebody else to deal with, because that doesn't accomplish what we're trying to do. And the net result is the crop usually loses quality. Trying to fix that problem. So we got the potatoes in the truck's going down the road. Put a tarp on it. Tarp those trucks before they leave the field. I haven't seen a truck in the West in 15, 20 years going down the highway without a tarp on it that's loaded. They just don't do it. And so the reasons they don't probably are the same reasons you shouldn't. And it takes 5 minutes to roll that tarp over and strap it down. So it's not going to delay harvest by a week or anything like that. And your potatoes will get where they're going in much better shape. So it's worth doing. Unloading the truck, whatever the device is that's going to receive those potatoes should be running at pretty much the same speed as the belt that's coming out of that truck. So your potatoes are flowing like this. They're not bunching up or being carried away quicker than they're brought in, which means it can hit each other and bounce around, which causes damage. So match those speeds. You can use a digital tack or a belt speed instrument or whatever you want to do to check that. And because those are all mechanical driven, they don't change. Once you get them all set right, you're good to go. You don't have to go back next week and check them again, because the number of teeth on the sprocket isn't going to change. And you can't always get them exact. We can't buy a 20.5 tooth sprocket. We've got to buy a 20 or a 21. So make sure they're as close as you can get them.
Our truck bodies, I believe the belts are 28 inches wide on them.
Okay.
And what we're delivering into is, I think it's 24 inches. We're headed the wrong way. But anyway, just discussion.
All right.
I should know how wide our stingers are. Ryan here, how wide are stingers?
Well, they got the rockets on the bottom. The belt itself is only 24, I think.
Okay, so I bet just
Okay.
Just explain to you where we are. So also
All right.
And the self-unloading trucks, our flow starts out probably, it's at least 12 inches of volume on top of that. So we're trying to come down into a letdown device now. I'd like you to go back to that letdown device and just give us one more picture there. So
Okay, all right.
On if our head roller is, Lord, where's Dale? You know, how big is that roller, Dale? Is it 18 inches across it, that big roller on the zinc letter box?
Yeah, I'd say that anyway.
I'm sorry, I should know those numbers, but, so regardless of that, would we go down to the, if you draw a big round roller there, I guess where could we attach the letdown device? If our roller is,
Okay.
our number here is 18 inches diameter, would we start just at middle dead center? Is that a terminology that makes sense?
Well, a little above center.
Okay.
I'm going to draw the belt in red. And we're going to put a great big roller on the end of it.
Yeah.
So our system looks something like that. And we're feeding that into some sort of a device that will carry those potatoes that direction. All right. Get this piece set at 105 feet per minute. That's the maximum speed you want those potatoes to be moving. If you exceed that, you've got velocities that are great enough to, when they hit something that isn't moving, they're going to damage, one or both. So once you've set that, then you have to run this speed to deliver what this belt can take away. So if you got too much flow coming out here, you're going to overload that. Potatoes are going to fall on the ground, and right away you got a problem you don't want to see. So this, I don't know how variable the speed on these belts is.
They're all variable speed.
Okay.
Mostly electric, what do you call it, inverters.
Okay.
Where there are three-phase motors on them, and we power them with single phase.
All right.
So just, and our speeds, I should know the belt speed there, but I don't.
Okay.
It's relatively a lot slower than 105 feet per minute, I'll tell you that.
All right. If we look at this belt in a cross section, we've got our sidewalls here and our belts sitting in here. This is looking at it from an end view. So when we put potatoes on that belt, we want that pile to look something like that. We want it as full as it'll run without any of them falling over the sidewalls. So if we've got that running at 105 feet a minute and we've got a full belt there, then this is delivering at just the right rate. If we're overloading it, we're going to get them on the ground. Somebody's going to have to pick them up. That's not fun. So we want to slow this down. If we don't have a full belt, then this could run a little quicker. So depending on how much dirt and other things might be in there and how much capacity the equipment that follows this has for cleaning, we might want to run slower because we're overloading the star roller table or something beyond that that's not able to handle everything we're given to it on a per minute basis. So if this is variable, that makes it a lot easier. Then you want to run this as fast as you can without hurting them and fill it as full as it can carry them. If you overload it in time, you'll burn that motor out because you're working it too hard.
I think the issue we have, though, is that our dirt eliminator and the conveyor systems going to our bin piler can't handle the fast flow coming from the truck.
Okay.
Or the bin piler will just plug right out.
Yeah. There's always a weak link somewhere. And so you start with the smallest volume device in the line, and that's probably this 24-inch width stinger. And you run it as full as and fast as you can afford to do. Then everything else will be running at less than capacity, but you can't make this work any faster without hurting yourself. And you don't want to create your own losses.
So on the let-down device on your red belt there, where
Mhm.
would we,
Okay.
where on that circle might you suggest that would go?
Well, this is your point. Here's our pivot shaft, an angle about like that. Just below that, we can put that piece of flat steel in there and then put our let-down belt, which is going to be held up like that or up here. It'll have to be supported on each side and across on the belt here. So you want the steel not to touch the belt. That'll wear holes in it. But you can have this let-down belt touching the belt. In fact, a lot of guys will do that. They'll go through and cut it on an angle so it's a pretty fine wedge to get everything to go down the belt and not get hung up in between it.
What we've done there is if we use 2.5-inch flat iron section on the weld across there to start to bolt the product to, then I've tried this on and I just want to ask you about it. We bolted our belting on, but we use a piece of 2-inch that
UHMW?
different that white product.
Okay,
And then if it touches the belt, on that approach is clean, if it touches the belt, it doesn't hurt our truck belt any.
okay,
It has some, it'll soon wear right to the, and then it's close enough to the belt that dirt doesn't build up under it and cause trouble. And then, you know, you could adjust that back if you had to, but in a way, do you have an opinion on that, or is that?
well, yeah, that's perfectly good. The whole point of all this is to take gravity out of the transfer from this belt to that one. We just don't want a free fall because that's going to exceed our 105 feet, and the impact is going to damage the tissue. So if we can take gravity out of that process, so that all gravity is going to do is hold them down on the belt here, and then we'll let them down by our method, and then let gravity hold them on the next device going forward. So anytime gravity has a chance to change elevations, it changes the velocity or the speed they fall. The farther they fall, the harder they hit. And so we don't want gravity changing from one piece of equipment to the next without any mitigation there. In this case, this let down slide. And that slide is usually in a curve. That's the way those belts are put in there. So they're supported on the upper sides, and then they just kind of hang free. And then there's a piece across just outside of the head roller that holds it in place there so stuff doesn't get down behind it. Because pretty soon you'll have a wadded vines and dirt and stuff in there, and it's not fun cleaning that out. So use the weak link in your chain of all your equipment as your standard for where you start. And then the volume that it can handle, maxed out, is the maximum you'll ever put in the rest of the equipment. So that might translate down the road into replacing these with wider units or rebuilding them and putting wider belt or chain on those, because that will allow that truck to unload quicker, get back to the field, get more loads a day in. And so those are, management decisions. You weigh all the variables and the consequences and the benefits and make your best call. So again, when you transfer from equipment to equipment, don't let them drop, and make sure one device is feeding at the same rate the next one's carrying away, so there's no bunching up. And if you've got a string of conveyor tables strung out to go from your cleaner, which may be outside, to your piler inside, then make sure that there's no openings between the ends of one belt and the next one for any potatoes to fall through. Little dirt can fall through, that's fine, but you don't want the potatoes down there on the ground. So that's just the way you bolt them up together, and the spacing that you use to set them. And when you get to the piler, coming off the end of the conveyor, the drop into that piler is generally a problem, because pilers are built so that nothing ever touches anything, can't wear. And they put the same size bearing on the whole machine. The bearing is the biggest one they need for the heaviest workload part, but so you don't have to carry 50 bearings in your parts room, or all the rest of them are the same size. So they're overrated, but it's a cost savings in some ways. So the bottom of the bracket that holds the delivery conveyor that's coming to the piler, typically, if it's a red machine made in some place called Idaho, the lowest drop you can get is 22 inches. That's unacceptable. Remember our 8-inch max? Well, we got to figure out a way to solve that. And the easiest, quickest one is a letdown. Another piece of belting, just like this, that allow those potatoes to get from the conveyor into the bowl of that piler and then go on up the elevator. There are other ways to do it, but they're more complicated and they require more fabrication to make it happen. You want to keep all the flexibility in the machine, so if your piler's kind of headed this way and your belt's coming in at an angle, that bowl's still going to work for you. And the letdown will as well. But, you know, they build them so that they'll last. And they do. Because if nothing touches nothing, nothing wears. But they aren't looking at it from the standpoint of maintaining the quality of the crop that's going across that machine. And that's where the money is. So, you know, put that as the highest priority. We've got to maintain that quality. How do we do it? There may be a dozen different ways, and then maybe all of them work. Some might be easier to do than others. So that's the trick, is to figure out what approach you're going to take, how you're going to make it happen, put it together. Usually there's the original version, then there's the first modification and the second, and by about the third one it works pretty good. You don't often get it dead right the first time. At least I don't. And then build that pile in lots of tiers. You can't have too small a tier, but you can have too big a one because of that roll down, backside and front side. And so the smaller those tiers are, the less they can roll, the less chance there is of any damage or breakage. You know, if you have a potato with an odd shape or a knob on it, there's a good chance that can get broke off in tumbling. And that opens up tissue that decay organisms, which are in all that soil, might find a nice opportunity to cause some problems.
We're using the tiers now to fill our building. I'm just sitting here thinking, but as we take them out, we're using these, here we seem to like those, I use the word pause, or
Yeah.
belt system on
The
to
scooper.
fill the bin. Is there any simple method to help you now with the roll down coming out? Because they are coming across the top at whatever
Well,
speed they want to come.
the fact is that the slope of that pile face when you're building it is shallower than when you're unloading it. Because you've got to get to that point where they'll break free to get those high ones down where you can get them in the truck. Yeah. Yeah. I've seen overhangs when the sprouts get out of hand a little bit. Kind of spooky.
Is there any ingenious way of slowing this down?
Not that I've seen. Now, if you have a humidity issue in your storage through the winter, which might happen, and you get what they call pressure bruise, they're little kind of indentations where potatoes pressed against each other. Those indentations are extremely fragile to bruising. The same as a potato that loses moisture and gets a little bit soft is extremely fragile to bruising. That's just tissue that's in a localized zone that didn't have enough capacity to hold its water inside, and that recess developed in conjunction with touching a tube or another potato. If you look at those pressure bruise spots, if you go collect some of them and start peeling them, wait them a couple days so they can color if they did get bruised, almost every one of them will have a bruise in it just from rolling down the face of the pile.
So you go through all the work to put these potatoes in, no bruise on them, let's say, and then at the very last moment of taking it, beans, you're bruised.
Yeah.
So I mean, what's the point of doing all this
Well,
if you don't have a remedy at the other end?
The damage is cumulative. You get a little here, a little more here, a little more here, a little more here. Pretty soon you're starting to get on the ragged edge of making grade. So if you can eliminate the ones you can control, then the few that you can't aren't going to hurt you and put you out of grade on a particular run. So the idea is to get the least amount of damage possible. And even some of the storages that have flume channels underneath the pile, where they just pull boards and let the potatoes gravity feed into water and off they go, they've got the same problems. Because you can't get that pile that's 24 feet high in some cases. How do you get that potato down to here without any injury? We don't know yet.
Coming out of storage, one good thing about it, coming out of storage, when they start to sit, the straighter they are standing up, generally caused by they're warming up some.
Mm-hmm.
They, to me, at that time, I seem to feel that they get more bounce in them than they did when they were going in.
Well, they generally are a little softer, and that's because they've lost a little bit of water. You can lose water out of that tissue by having a lower moisture level in the air around the potato than the water concentration inside. So you're going from a higher concentration to a lower. It's like high pressure to low pressure. Problem is we can't reverse that. The only way we could put water back in that potato is if there were still some roots attached to it and the roots were still functional. Well, that doesn't happen. The roots are too fragile.
So can we prevent pressure growth?
Yeah,
And after harvest,
yeah.
just by the humidity around the potato?
Maintaining as high humidity as you're physically able.
And what is that number?
That's a number in the low 90s, 92 to 94% generally. At 95%, a quarter of a degree Fahrenheit puts you at 91 or 97. The temperature, get a sling psychrometer chart. You can see how it's curves that are going like this. And up here, a very small change in temperature means a huge difference in moisture holding capacity. So it's a parabolic curve, or 1/2 of one. And so we can't hold storages to a quarter of a degree in a 24-hour cycle. We just don't have insulation and system capacity to do that. We can hold them to a 1/2 degree. The newer storages that are well instrumented and equipped can maintain less than a 1/2 degree change in a 24-hour period throughout the entire time the crop's in there. And so it's really a case of what's your storage's capability. If you're trying to...
Storage here that we constantly have pressure growth problems.
Okay.
And I always blame it on the potatoes, but it's not something.
My guess is that it's a combination of insulation and humidification. And if you've got insulation issues where there's cold coming through places, you get the humidity high, it will condense on those cold spots and start dripping. I don't know if you're seeing dripping on the top of the pile at certain times in the cold part of the winter, but that would be an indication that there's...
Not enough insulation in the attic.
Yeah, yeah.
But that will transfer into pressure growth.
Because you can't hold the humidity high enough because of the condensation that's going to make your pile rot. You got to back the humidity down. That raises the gradient between inside the tuber and outside in the air. Water leaves. So we end up with marks on our potatoes that we just wouldn't like to see if we had a choice. Many of the newer storages now being built in the West and perhaps here on the island too, and I don't know that, have sloping sidewalls. If you look at a storage from a structural engineering perspective, when you put the pile in there, the sidewalls kind of want to do this. You got lateral pressure from the pile wanting to squeeze out and push against the walls. So if you have straight vertical walls, they must be much stronger or they bend and give and may fail. By putting slopes to those walls, as the pile settles, it actually pulls away from the walls. So you can build a much less expensive storage, lighter weight construction materials, and not have any of those lateral problems that come with straight vertical walls. So there's some engineering involved there that really helps make life easier. And if we knew enough, we'd make it.
So does that prevent pressure roofs?
Not specifically. But the difference is those are double walled buildings. They're steel on the inside and steel on the outside, insulation between them, so that it makes it much difficult for the cold to come through, and the airflow is uninterrupted. It's a smooth surface. So you don't have those vortexes of possible places for moisture to accumulate. Immature potatoes, those little guys that formed late in the year, didn't get very mature by harvest time, are the first ones that are going to sprout in your storage. Those and the ones that are decaying. The potato has several survival instincts, if you will, to be sure that it doesn't become extinct, to perpetuate itself. So a potato that's starting to decay senses that and tries to put out a sprout to grow again before it's all rotten. So it's a natural mechanism. There are some products on the market now. They're proteins. It's called the harpin protein, that are extracted from plants. All plants have them. They do not have to enter the plant to affect what they do. There are receptors on the surface of the foliage, or the tuber, or the seed. This harpin protein just has to make contact with that receptor, and it causes the plant to react in a way that it would have had a disease attacked it. So it wakes up its natural disease-fighting mechanisms, and so that plant is already ready to fight before any kind of decay shows up. So it's kind of like getting a malaria shot, and then the mosquito comes along and wants to infect you. You're already protected. And we're doing things with those products in trial work that I'm doing that are just phenomenal. 2 ounces of that per acre on corn seed, where you have risks of the corn smut disease, cuts the smut 60%. Yeah. Works on all kinds of plants. They're called systemic acquired resistance, or SARs, and there's a number of different products on the market. They were originally developed by some researchers at Cornell, and they thought they had such a great thing, they all quit the university and started making their product, and then found out business was tougher than they thought. But they've been sold a time or two to other companies, and now they look like they're in pretty stable hands, and they're on the market and doing some really good stuff with them. So we put them on potatoes, and we greatly affect the Pythium, the Verticillium, the Erwinia, the early and late blight. Because the plant's are ready to fight before those diseases find it.
So Russell Burbank is successful with the verticillium well.
Mm-hmm.
So if we put that on our seed, then would that yield?
It makes for a healthier plant,
Well, yeah,
and that translates into a more productive outcome,
it could give you less sugar in,
possibly.
and it causes stress.
Sugar ends is a stress response. A few years back, Idaho had a terrible time with it, and they couldn't find any cause and effect relationships. A lot of folks were looking at it. An extension agent from Ontario, Oregon, a guy that I knew, worked with him for a number of years in the same company, went out, he planted some potatoes on the standard 36-inch rows that Idaho, everybody does, and he planted some right beside it with 34-inch rows. 36-inch had serious sugar problems, 34 is none. So then we started going back and, okay, now what else is happening here? What's going on? The wider your row spacing, the more times sun will hit the ground and reflect back to the bottom of the leaf. If you've ever been spring snow skiing it might only be 50 degrees out there, and you come home with the worst sunburn you can imagine, because that light's hitting and coming back in a different direction than you're used to. That stress, that early in the year before row close, translated into sugar problems at harvest. So there's a lot of neat stuff going on in a lot of places.
I eat a lot of Vegas, but I didn't know this much of it.
Well, they got big tubers there, but I don't know you can market them.
This would be just a simple little chat on the potatoes. No lots of my own.
Yeah. Well, there are so many things that we haven't yet achieved with the potato crop. If we go and look at the very best genetics one could lay their hands on in Russet Burbank, about 1 out of 40 seed lots that I'm familiar with in the West would be that good. But the genetic yield potential, not what the grower's getting today, but what that plant could have done, is way over 100 tons per acre. And we think we're doing something with 40 tons. We haven't scratched the surface. Some of these bigger farms that I work with, I can go out there in the middle of August when that crop has another 6-7 weeks to grow, green as grass, before they die down. And in 30 minutes, I can find a plant with 10 pounds of potatoes under one hill. Not hard at all. That's 75 tons. And he didn't water or fertilize or anything else for that much yield. So what that's telling me is our inputs right now are good enough to double our yield. We don't have to spend another dime if we fix some of the factors that are limiting our crop. One, the genetics of the seed you buy, the physiology, the morphology.
We've seen that here, some hills have,
Yeah,
you know, I don't know about 10 pounds, but
6 or 8.
yeah,
Yeah,
see, that's seven, how many tons you say, 100 tons?
100 tons is very doable.
That's $7 per pound a acre, we're getting one.
Mm-hmm.
I don't know, I'm not super, but that's the difference.
It is. And when you see a plant with that kind of a crop under it, that's telling you your inputs were good enough that that happened. You did it.
You wouldn't want to be hanging on the branch, would you?
Well, so you know that it's doable. Right now, we've got too many things we compromise in the interest of convenience or expedience or cost and say, okay, this is just the way we do it. But when a plant out there shows you that it can do twice what you're getting, it says that's not out of reach. Now, what's different about that plant than the rest of them around it? That's what we got to figure out.
So in your research, like, have you laid the tubers from these plants in the big hills?
Yeah.
And do they replicate again?
Generally, not always.
Yeah.
Depends on why they're big. If you had a low stem count, 1 or 2 stems, they're going to get real big. If you had a 3 or 4 stem plant and they're also 16 ounce, yeah.
Everything has to be the same.
Right, right. So we got to eliminate the factors that are keeping us from achieving what's possible. And my guess is that we start with seed. We've got to find seed with yield potentials way above what's commercially available out there. And that's being done in some of the states where they do tissue propagation at the university level, and they're screening these sources of tissue based on history of production. So plants that don't have a 50-ton yield are tossed out. They're not considered even candidates. And of those that do, then they start screening those and following up a year or 2 or 3 years later to see if it held true. And then when they find those that are, then they start multiplying that into nuclear and then foundation and then generation 1, 2, 3, whatever.
So when they start to clean, I clean that up when they go nuclear. Do they lose, plant potential then?
No.
No.
The genetics doesn't change. One of the things that might be coming down the road, all of the problems we have, the nematodes, the soil pathogens, the insects, the diseases, all those things can go away completely with GMO modifications. There are wild type potato plants out there that don't get these problems. They're immune to them. So all we got to do is take that potato gene and put it into this cultivar that we're going to grow commercially, and that problem goes away.
So is that cisgenic or transgenic? I don't know.
Well, it's transgenic basically because you're crossing this with that. So it's not within the gene, it's something you're adding to it. And there's a, from the population, there is some segments that are resistant to the GMO approach because they don't understand it. Every major advancement that occurred over the last 50, 75 years in agriculture met the same kind of opposition. After World War II, when dry fertilizers first appeared, oh, you're going to kill the land, you're going to sterilize it, all the people are going to die, the animals are going to be gone, you're going to wipe the planet clean. That was the hype that they were putting out. Well, after 10 or 15 years of time, and none of those terrible things happened, these people start losing the credibility they had because they were talking about an unknown. Well, the unknown didn't show up. And so it becomes accepted. Same thing happened when irrigation became a viable option for farming. Oh, you're going to wash all the soil away, you're going to ruin the topsoil, the land's going to go to dust. You know, everything terrible they could think of was promoted. 10 or 15 years, none of it happened. Bigger crops, better quality, more food, cheaper. They kind of went away. Well, we're almost into the 10-year cycle now on the GMOs. So between now and the next 5 years, all the terrible things they thought were going to happen are going to be failing to appear, and there'll be a general acceptance that this is better technology than we had before. And there is nothing unique about the 4 amino acids that make up a gene. And there's a string of those that give you the trait or the characteristic. So those 4 amino acids are in the DNA of every organism that's alive on this planet. The same ones in the DNA on every species. It's just the sequence. So it's not like we're adding something new, a whole different chemistry. We're not. It's the same stuff. It's just in a different order. And the different order causes the characteristic or the trait to appear that wouldn't have happened if they weren't in that order. So that's going to happen through plants probably first, and then it'll go through animals. And then somewhere along the way, people are going to get involved in all the kinds of illnesses and diseases and problems that the world faces are going to become less and less important. But something new will come along, you know. We aren't short of problems. Do we want to go toward fertilizer, or should we cover some other things first?